Good evening. Welcome to SAKALAVIDYA YouTube channel. Om Shri Krishna Yadav, Vaishnav Vinayaki, Sai, Tejasvi, Uma, Balu, Swati Singh, welcome. Uma, welcome. Balu, welcome. Santosh Veera, Narendra, Manjula, SAKALAVIDYA YouTube channel. Rama Devi, Seshank, Shankar Narayana, Tejasvi, Vaishnavi, okay. Shiva Ganesh, Seshank, Lokesh, Sai, Govardhan Yadav, Chandana Sri, Jitendra, Vital, Bhavana, K. Rajkumar, Avinash regular. Where is Sumant, Sam? Good evening all. Deepika, Idris, Jitendra, Bhagya Deepika, right. Mannam Divya, also after long time. Okay. Shiva, Hare Krishna, Gayatri Reddy, Lavanya, Vittal. Okay, Vittal. Okay, you are not new. Morning you might have attended. Okay. Sunil, Rajesh, Balu. Right. Prasanna Hani. Yes, after long time. Rajasekhar. Hare Krishna. Hi. Enough. One time is enough. Murthy. I don't have any idea. Wait now, because we have still 2 minutes time is there. Because our regular viewers definitely they will join. Okay. Okay. Kondagari. Anila. Satish Kumar. Yes, in September I will take. Okay, it's all right. It's all right. Chandra. So all of you like, subscribe and share. Okay. Once again, welcome to our SAKALAVIDYA YouTube channel. Sorry you're suffering. Where are you from, Raj Kumar? Will you suggest any medicine? क्या करो ना? कुछ भी नहीं करो ना. How many marks P and C will come in Eamcet? Sorry, you were great teaching. Thanks for responding. Okay, our regular viewers will give a phone number. Don't worry. Okay. Right. Thank you. Right now, let us start now today session. So now today we confine to our discussion. We talk about. Thank you, Rajesh. Permutations, and tomorrow, day after tomorrow, after completion of the permutations problems. Okay. Thank you, Uma. Thank you. We start combinations. Okay, chapter name is permutations. Okay, permutations. So part 1. Swati Singh, morning, where had you been? Oh, okay, second year this is. So permutations, first actually we need to discuss here one concept. First one is fundamental principle. Fundamental principle. Fundamental principle of counting. Fundamental principle of, okay, are you okay now? Get well soon. Fundamental principle of counting. In that one actually we discuss one multiplication principle. Multiplication principle. Second, we discuss addition principle. Addition principle. Actually, this chapter basically is known as counting. In that counting, we have the two principles. One is multiplication principle, another one is addition principles. Okay. What is multiplication principle? Let's have a discussion on multiplication principle. Okay. So first, what is meant by the multiplication principle? So now let us discuss on multiplication principle. Multiplication principle. Okay, see, for example, say this place is, for example, this Hyderabad, this is Hyderabad. For example, this place is something, you can say Kurnool. Say this place is, for example, you say Bangalore. This is Hyderabad. For example, say this is Kurnool, this is Bangalore. For example, let us consider, if a person wanted to travel from Hyderabad to Bangalore via Kurnool, how many ways? Okay, thank you. How many ways can a person can travel from Hyderabad to Bangalore via Kurnool? For example, you take like this now, from Hyderabad to Kurnool, for example, you have, suppose, 3 ways. For example, 3 ways. For example, from Kurnool to Bangalore, for example, you have 4 ways. 4 different ways to travel from here to here. 4 different ways. How many ways can you travel from Hyderabad to Bangalore via Kurnool? This is the question. For example, let us count it. How to count? For example, say from Hyderabad to Kurnool, say this one is A1, this is A2, say A3. From Kurnool to Bangalore, say this is B1, this is B2, say B3, this is B4. That means now here, for example, from Hyderabad to Kurnool, A1, the chance is like this actually, A1, B1. So he can reach or she can reach Hyderabad like this way, or A1, B2, or a1 b3 or a1 b4, or you can choose a2 route and a2 b1 you can travel, that is a2 b2, a2 b3, this is a2 b4. For example, if he or she chooses a3, a3 b1, a3 b2, a3 b3, a3 b4. Now count total how many are there, how many actually ways, number of ways, 1 1 2 3 4, 1 2 3, that means number of ways is equal to number of ways equals to 6 ways. But instead of doing this the lengthy way directly without counting also, number of ways we can write like this. Number of ways means just you divide Hyderabad to Kurnool is one task, divide into one task. From Kurnool to Bangalore you divide into second task. This is second task. Say this is first task, this is second task. First task, you say this is second task. Task, or you can say work also, no problem. This is first work, this is second work. Here you check it now, here background wise nothing is there, it's closed room this is. So if the first work can be done how many ways now here, the first work, for example, the first work can be done in 3 ways, in 3 ways, in 3 ways, in 3 ways. Second work can be done in 2 ways. These both works can be done, second work followed by the first work in number of ways is equal to, number of ways equals to, you can write like this, 3 times 2, because here we have 6. This is called multiplication principle. This is called multiplication principle. So what is the multiplication principle means? You remember one thing. For example, if you treat the first task, first work as one operation, second work is also other operation. If first operation can be performed in m different ways, second followed by the second operation can be performed in n different ways, these two operations in succession one after one can be performed in m into n ways, mn ways. That is called multiplication principle. Not only for 2 works, it can be extended for more works also. That means first work m ways, second work n ways, third work p ways, and so on. So in succession these all operations can be done in m into n into p into dash dash n, p ways also we can write it. This is called actually multiplication principle, right? Okay, now let us write multiplication principle concept. Multiplication principle. Multiplication principle. If an operation or work, if an operation can be performed can be performed in m different ways, m different ways, following which a second operation can be performed in n different ways, then the two operations in succession, that means one after one, in succession can be performed in m into n ways. This is called multiplication principle. Sir, please check to second task is 4 ways. Yes, second task is 4 ways. Yes, exactly. 4 ways means A1, B1, A1, B2, A1, B3, A1. 1, 2, 3, 4. 4 into 3. Yes, exactly what you said. I did mistake here. Okay, thank you for reminding me. So that means 1, 2, 3, 4, 12 ways. This is 12 ways. Now this is 3 ways and 4 ways. This 3 into 4 is 12 ways. Sorry, absolutely correct. Right. If an operation can be performed in m different ways, following which second operation can be performed in n different ways, the two operations in succession can be performed in m into n mn ways. Okay, so that means actually now this can be extended for the finite number of operations also. So finite number of operations also. So that means now you can write like this. If first, second, third, so on operations can be performed in m comma n comma p so on dash different ways. Okay, then they can be performed in succession, one after one, in succession in m into n into p into dash dash ways. Even it can be extended for finite number of operations also. finite number of operations also. Okay, this is called multiplication principle. Example also we have discussed. So next let us move to the next concept. So next concept is addition principle. Addition principle. Addition principle. Addition principle. Addition principle. See, for example, this is a, for example, cinema hall. Okay, a cinema hall has 1, 2, 3. 3 entrances. 3 entrances, for example. This is 2 exits. How many ways can a person enter and will go outside of the cinema hall? How many ways? So that means actually either he may choose, he may enter in this way and he will go like this. So that means this, if you treat this one is 3 ways, this is 2 ways, total 5 ways. 5 ways. 5 ways means we can write 3 plus 2 ways. This is called addition. This is called addition principle because it is independent. So these 3 can be done in this operation can be done independent ways. This is second task is 2 independent ways. The both can be done in independently. 3 plus 2 is equal to 5 ways. This is called addition principle. So that means let me write the addition principle here. If an operation can be performed in m different ways, another operation which is independent, not followed, which is independent of the first operation, can be performed in n different ways. N different ways. Then either of two can be performed in m plus n ways. So that means an addition principle is called exclusive principle, whereas the multiplication principle is called exclusive. That means either, there actually either means, either sense means you need to use plus sign. There both means multiplication. You remember one thing. So this we need to remember in the principle. See, both means multiplication. Either means, either sense means you need to use plus. That's a very simple logic. You need to remember this one. Both means you need to remember multiplication principle. Either means always remember either, chance, either or, that is plus. Both means followed by definitely you need to use multiplication principle. That in the while doing the problems actually we come across these words, these keywords. If you find these keywords both and either in the problem, whenever both is there you need to use multiplication, whenever either is there you need to use plus sign. That you need to remember. Okay, even this can be extended for even more than two operations also. If first operation, second operation, third operation can be done m in m n p ways. Next, either of them can be performed in m plus n plus p ways. That also we can write it. It can be extended for more than two also. Right. So next, this is very important concept now. Permutation. What is meant by the permutation? Permutation. Permutation. Okay. What is meant by the permutation here? Permutation means, you remember, permutation is nothing but arrangement of the objects, arrangement of the things. So that's called actually here permutation. So permutation of the things means actually each of the arrangement each of the better is say different arrangements, each of the different arrangements which can be made by taking some, few only, some or all of given number of things or objects at a time. Is called a permutation. Is called a permutation. That means permutation means arrangement. You must remember one thing. Permutation means arrangement. So very simple way you can write permutation means arrangement. You can ask one doubt, what is combination, sir? What is the difference between permutation and combination? Combination is the selection. Okay, permutation means arrangement of the things. So that means arrangement of the things can be done. How can you arrange the things? How can you arrange objects? So these things or objects can be arranged in linear manner or circular manner. So that's why now we get two types of the arrangements. The two types of the arrangement means two types of the permutations. We talk about two types of permutations. One is linear permutations and other one is actually circular permutations. Unless it is mentioned, we need to consider as that is actually linear permutations itself only. Linear means in a straight line, in a line the objects are arranged. Okay, right. So permutations are actually how many types? Actually, here we have two types permutations. One is linear permutations. Linear permutations. Second one is circular permutations. Circular permutations. Now during these sessions we talk about these two permutations, linear permutations as well as the circular permutations. First let us concentrate on actually here now the linear permutations basically. So next after linear permutations we discuss or we talk about circular permutations. Thank you. So now important points. Important points. First one. First one is here the number of different permutations, permutations of n different things, taken or at a time, is denoted by NPR. P stands for permutation, or n of p comma r, where you remember, where you can write like this: 0 less than or equal to r less than or equal to n. 0 less than or equal to r less than or equal to n. So the number of different permutations and defined as NPR equals to, anybody, what is the value of NPR? What is the value of NPR? What is the value of NPR? Anybody? Okay, n factorial by n minus r factorial. Very good. How did you get it? See, this one, brief discussion, let us have this one now. Okay, NPR. So what do you mean by NPR? Means actually here take r blank places. First place, second place, third, fourth, and so on. This is rth place. Say this is first place, second place, third place, fourth place, and so on. This is rth place. Now here see, the r places are being filled with n different objects without repetition. Here NPR means Sumant. Okay, welcome. So here NPR means the number of ways of filling or empty places with or using n different things without repetition. This is the meaning of NPR, actual meaning of NPR. Okay, Sumanta. See, the first place there is a chance. First place only we can accommodate. Omshi Krishna Yadav, please chart in English itself only. This class is meant for absolutely Telugu, not Telugu, English medium class, English medium section. Please try to understand. Okay, so don't chart in Telugu now. It's not Telugu. See, in each place only one object can be or one thing can be accommodated. That means out of n here there a chance is n ways we can fill. Now already one is filled. Now remaining how many things are there? N minus 1. So this can be filled n minus 1. Already first place can be filled n ways. Second place is n minus 1 ways. Third can be filled n minus 2 ways. This is n minus 3 and so on dash. Here very interesting factor I will tell you. For example, you take the first place. First place is n ways we filled. Second place is n minus 1. So n minus 2 can be written like this. N minus 2 plus 1 ways you can write. Third place. This third place can be filled n minus 3 ways. N minus 3 can be written like this. N minus 4 plus 1 ways you can write. And so on. Now rth place. Rth place can be filled in how many ways? That is n minus r plus 1 ways. So that means this can be filled n minus r plus 1 ways we can fill. Now, why should we actually discuss about the multiplication principle? Here the multiplication principle plays vital role in this concept. What is the concept means? Now actually I treat this one as first work, this is second work, this is third work, this is fourth work, this is rth work. Now I can say like this: the first work, comma second work, comma third work, comma fourth work, comma so on rth works can be performed in n ways, n minus 1 ways, n minus 2 ways, n minus 3 ways, and so on n minus r plus 1 ways. So all these works can be performed in succession how many ways? That is nothing but NPR. So we get the NPR. Here NPR equals to, we get n into n minus 1 into n minus 2 into so on n minus r plus 1. That is the formulation. So that means now here we can write NPR equals to number of ways of filling or empty places using n different things. So that means first work can be done n, second is n minus 1, n minus 2, and so on dash dash n minus r plus 1 ways. This is NPR formula. But after prior simplification, if you multiply this both numerator and denominator with n into n minus 1, n minus 2, and so on dash dash n minus r plus 1 multiplied by n minus r factorial upon n minus r factorial. This n into n minus 1, n minus 2, n minus r plus 1, n minus r factorial can be written as n factorial by n minus r factorial. Now this is the formula for NPR. NPR equals to n factorial by n minus r factorial. So this is the formulation. Understood all of you? This is NPR. Right. Now, right. Second point. What is NP1? Now you need to chart. What is NP1? What is NP1? What is NP1? What is NP1? Very simple. NP1 means one place, only one place is there. We need to fill with n different things. Then that can be filled n ways. NP1 is n. Understood now? NP2. See, NP2 is equal to 2 places. You take 2 places, we need to fill. How many ways? N ways and n minus 1 ways. These two can be done how many ways? N into n minus 1. Now you can write NP3, NP4. You can write NP5. You can write NP6, NP7 and like that. You can write all these values. This is n into n minus 1 into n minus 2. 3 means up to 2. 3 factors. There should be 3 factors. N, n minus 1, n minus 2, n minus 3. N, n minus 1, n minus 2, n minus 3, n minus 4. So now NP6. What is NP6? N into n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. Okay, understood all of you? This is n times n minus 1, n minus 2, so on, n minus 6. Okay. Next, third point, NP2 by NP1. NP2 by NP1. What is the value? NP2 by NP1. NP2 means n of n minus 1 upon n. N cancel, n minus 1. Next, NP3 by NP2. NP4 by NP3. So now NP5 by NP4, NP6 by NP5, NPR by NPR minus 1. This is the observation. This is our observation. This is our observation. See, very simple now. How to remember means simple n minus 2, n minus 3, n minus 4, n minus 5, n minus of r minus 1. So what do you get now here? This will be n minus 2, this will be n minus 3, this will be n minus 4, this will be n minus 5. This formulation n minus of r minus 1 whose value equal to n minus r plus 1. This is important. Understood now all of you? Okay. So now I discuss one question here. For example, this type of question may be asked in the examination. See, NP5 is to NP4 equal to 8 is to 1. Then n equals to. What is the answer? What is the answer? You check the problem. NP5 is to NP4 is equal to 8 is to 1. Then what is the value of n? See, NP5 by NP4 is n minus 4. Here see the solution. See, NP5 by NP4 equal to 8 by 1 8. So n minus 4 equals to 8. N equals to 12. So in a speed manner with accuracy we can solve the problems using this concept. This concept is very, very important for us. Okay, thank you. Thank you. Fourth concept. Fourth concept. Okay, thank you. Fourth concept now. Right. So now number of permutations, of n different things taken all at a time, is NPN equals to. See, NPN means here first place, second place, third place, fourth, and so on. Here n places. First, second, third, fourth, so on, nth places are filled with n different objects without repetition. So that can be done like this now. How many ways we can done? This is n ways, n minus 1 ways, this is n minus 2, n minus 3. This will be what we need to write. N minus r plus 1 means r is n. N minus n plus 1 ways. So this place will be 2 ways. This place will be 3 ways. So that equal to what you can write now? NPN equals to n multiplied by n minus 1, n minus 2, and so on. 3 into 2 into 1. This is nothing but the definition of the n factorial. So this we can write n factorial. So that's why npn equals to, we get n factorial. This is the hint. With this concept we get npn is equal to n factorial. Okay, now let us give some practice to you. Let us do. Some examples. What is 5 p5? 5 p5 means 5 factorial is 120. 6 p6, 6 factorial 720. 7 p7, leave it, no problem. 7 factorial, write down. 10 p10 is 10 factorial, leave it. Even np n minus 1 also we can write n factorial only. np n minus 1 is also n factorial. Next, fifth concept, fifth one. Okay, now for example, you take NPR. This I divide into two parts. Divide into two parts. So what is the first part? This is the first part. This is the second part. So what is NPR? Anybody? What is NPR? What is NPR? What is NPR? So that cannot be done, Anila, because this is a digital board. What is NPR? It's an interaction session. Understood now? NPR means actually the number of permutations of n different things taken are at a time. So that is actually NPR. So okay, NPR is a permutation. Okay, that's correct. N factorial by n minus r factorial. Okay, so now here you see the first part. So I would like to here first including a particular object, including particular object. This is the first part. I will take it. Definitely always out of n things, one particular thing including a particular object. So now particular object is not included. Now how can we arrange? So let us think now. Particular object is not included, here including a particular object. So that means now you take the R places now here. This R blank places, empty places, we can say 1, 2, 3, so on dash dash R places. So now here take R blank places 1, 2, 3 and so on. So now here see first place, second, third R, 1, 2, 3, rth place. Here what we have done here, a particular thing is included, object is included. Included means out of R places any way we can put it. Let us say A1 be the particular object. So for example, A1 is the particular object means, so this A1 object can be placed either in first place, second place, third place or R place. That means number of ways of the particular object can be placed is R ways. How many ways? R ways we can arrange. So that means this can be arranged in R ways. That means first work has been completed. R ways. So now we need to arrange the remaining objects. Already, for example, here A1 is blacked. The first place is blacked now. Already A1 is fixed here. A1 is fixed here. A1 is fixed. Now how many objects are there? Remaining objects. So remaining objects will be n minus 1. Remaining places will be r minus 1. That can be done. Second task can be done n minus 1 p r minus 1. First work r ways, second work n minus 1 p r minus 1. Both including a particular object can be done like this. R into n minus 1 p r minus 1. This is including a particular object, number of ways. Now excluding, we are excluding the object. That means we are excluding the object means out of R objects, one object is taken away. Remaining objects are how many? We have, out of n objects, one object has been eliminated. So we have n minus 1, but places are R only. The first place can be filled n minus 1 ways. This is n minus 2, n minus 3 and so on. N minus, this is n minus 1, n minus r minus 2, okay, ways. So that means this can be done n minus 1 p r minus 1 ways. So that means now we can write like this. NPR can be written like this. Excluding particular object n minus 1 p r minus 1, including particular object r into n minus 1 here, n minus 1 p r, n minus 1 p r minus 1. That's why this NPR can be stated as sum of these two, n minus 1 PR plus R into n minus 1 PR minus 1. We can formulate like this. We have one important formula. So all of you note down this formula. All of you note down this formula. So one more thing, remember, see, NPR is always a number. Remember, always you get a positive integer. One more thing you remember, NPR is always an integer. An integer. Okay, this formula is very, very important. You need to remember this formula. NPR can be written like this also. N minus 1 PR plus R into N minus 1 PR minus 1. Okay, right. Next. Sixth concept. Sometimes, see, out of n objects, some objects may be repeated objects may be there. At that time, how to find out the number of permutations? That we shall discuss now. the number of permutations of n things taken all at a time, out of which P are alike. Alike means same. Alike and are of first kind. Q are alike of and of second kind. And rest are different. Is n factorial by first kind is how many are there? P. Second kind Q. That means we need to write P factorial and Q factorial we need to write. Okay. If the objects are repeated for next P times and Q times, then we need to write to find out number of permutations n factorial by P factorial Q factorial. Some even third kind are there, or that is n factorial by P factorial Q factorial R factorial, we need to write it. Okay. So that means, for example, one example let us consider like this. Number of permutations of 6 things out of which first kind two are alike of first kind, rest are different is. Then how do you find? So that means total is 6, out of 2 are same but 4 are different. That means you can write 6 factorial by, you can write 2 factorial. 6 factorial means 720 upon 2 factorial means 2, which equals to 360. You can write 360. Don't write 4 factorial. Rest are different only. Itself only. Okay, thank you. We shall meet you tomorrow. Bye bye. It's not working now. Computer is not working.